Hello, welcome to Dynamics 365 Financial and Operation tutorial series. We are talking about the concept of object-oriented programming. In this video, in this session, particularly we will discuss about hierarchical inheritance. So, if you are watching this video, I am assuming that you already know about single inheritance and multi-level inheritance. So if you don't know about single inheritance and multi-level inheritance, you can watch our previous videos. I'll give the link of those videos in the description so you can check out, and it will be helpful for you if you already know about single inheritance and multi-inheritance. So in this particular video, we'll discuss about hierarchical, and the approach will be, first we will understand the theoretical aspects or what is hierarchical inheritance, why we will use hierarchical inheritance, and after that we will move to the practical session. So without wasting time, let's start understanding hierarchy. So in this slide you can see that we have A and we have B, C, D. Our A is integrating a particular class which is a base class, or we can say this is a parent class, and from that parent class if we will create another class B which is a derived class, and again if we will create another class C which is derived from the A class, and this is the derived class 2, and if we will create again a class D which is actually derived from class A, then this kind of hierarchy or this kind of structure of the code will be called a hierarchical inheritance. So you can also create another more class which will derive from the A class, so you can give the name E here. So I can say that this is the parent and this is the son, first son, this is the second son, and this is the third son. So B, C and D will extends the class A, and this kind of hierarchy, and you can see that it is creating a hierarchy. So as the name suggests, you can see here this kind of coding structure is actually hierarchy based. That means from the parent class we can derive B, C and D, and B, C, D in the same level actually present. So this is a hierarchy. That's why we can say that this kind of coding structure is called hierarchical inheritance. So now I'll say in the bookish language. So if someone will say what is hierarchy in X++ programming language, so you can say that hierarchical inheritance in the X++ programming language as utilized in D365 Financial Operation refers to a structure where classes are organized in a hierarchy, and with each class inheriting attributes and behavior from the single parent class. So our parent class is A here, and the child class BCD will be inheriting, and each class means B, C and D, E. If there will be any E, F, G, then this will be inheriting attributes and behavior from a single parent class, that is A. This type of inheritance fosters a clear and well-structured relationship between classes and allowing for the creation of specialized subclasses that build upon the functionality of their parent class. And hierarchical inheritance offers several advantages in software development. For example, I can tell the structure, code organization. In hierarchical inheritance, it's provided a structured way to organize classes within a system. Classes are grouped based on their hierarchical relationship, making the code base more manageable and understandable. One more advantage I can say that code reusability. By inheriting attributes and behavior from a parent class, subclasses can reuse the existing code. Common functionality is defined in higher level classes and reducing the redundancy and promoting the efficient development. Also, I can mention one more advantage, that specialization and customization. Subclasses in a hierarchical inheritance model can be specialized and customize the behavior of their parent class, and they can override or extend the methods. Also, it can add new attributes and introduce unique functionality tailored specific requirement. Also, one more advantage is maintenance and update. For example, it can change made to the parent class automatically propagate to its subclasses. So if we'll change in parent class, automatically it's propagate to its subclasses. So this streamlines maintenance tasks, as updates needs only be applied to the parent class and change are inherited by all relevant subclasses. Also, we can say about the consistency and standards. Also, we can talk about encapsulation and modularity. And this hierarchical inheritance promotes the modularity and data hiding and preventing the unauthorized access and ensuring the data integrity. Okay. Also, code testing, efficient testing and debugging also possibility. One more advantage is scalability and future expansion. Also, the last one I can mention, that it provides a clear hierarchical relationship. The hierarchical structure provides a visual representation of class relationship, and this aids developers in understanding the inheritance hierarchy and the flow of data and the functionality. So I hope what is hierarchical inheritance and why it is important, it is clear to you. Now we'll move to the practical examples and we'll write code and we'll explain how this hierarchical inheritance is actually working. Also, we will debug and show you the result also. So here you can see that we are in the development environment. So here you can see that we are in development environment and we have to create a new project. So that's why I am just opening the Visual Studio and we'll create a project. So from here, just click create a new project. Now from here, click Finance and Operation, then click next, and here we will give the name of the project Inheritance Example, and then we'll create the project by clicking on the button create. So you can see that our project created, and from here we will add a new item, and the item will be a class which is a parent class. So from here select code and here just type vehicle class and add it. So you can see that our vehicle class added in our project, and now we will add two more class, that is the bus class and the car class. So first we will add the car class. So code selected already, just type car class and just I'll add one more class which is bus class. So class already selected, so I just type bus class and I will add. So here our vehicle class will be the parent class and the car class and the bus class will be the child class. So here I will write some code for the vehicle class. So as you can see that this will be our parent class. So I am just adding few lines of codes, that is this two is actually instance variable or member variable of the parent class, and this is the constructor of this vehicle class, and we are adding two particular method. First one is info method which will print the height, width, and the run class will give one message that vehicle class is actually running. Okay, and this is the code for our parent class. Now we'll add some code for the car class. Okay, and car class will extends our vehicle class. So if we'll save it, you will see that it is saying one error, and it is saying that the class inheritance vehicle does not exist. Why? Because if you go to this class, there you will get a keyword final. So if you have to remove that, because if our class is final, then we will not be able to inherit that particular class. So we cannot inherit this vehicle class as this was a final. Now if we'll go to this car class and if we'll save it, this will be possible. So I have to type vehicle class and just put here final, and actually that time I actually missed out this one, but if this will be final, it will give this kind of error. Okay, cannot derive from vehicle class because it is declared as final. So this is the exact error if final keyword will be there in front of the parent class. So you have to remove that to inherit. So if this will be final, you will not be able to derive. Okay, now I'll write some code here. So in this class you can see that number of passengers is there in car class. I am adding one particular member variable for this particular car class. This is the specialization for the car class, and we have a particular constructor which is having the height, width and number of passengers is there, because we have to initialize via the object creation. So that's why we have written this kind of code. So inside this we are printing height, width and number of passengers. So this is not the good way to declare or write info message inside a constructor. So if you want to check that your particular member variable is actually initializing correctly or not, you can test this way, but you can also not utilize this particular line in the standard code or in the production. It should not be the best practice to write a info inside the constructor. And we have a particular run method which is actually calling the super, and which super means it will call the run method of the parent class, that is this particular class. Okay, and it will also say that I am car class, that means car class is running. This will also print this message also. So we have added one extra facilities or one extra properties here, and we initiated that value, and if it is needed, you can also copy this code, and you can also paste it here also to see the height, width and number of passengers for the car class. So this is a particular hierarchy. So we can say that vehicle class is a parent and car class is a child. Now we will create one more child which is a bus class. Okay, so we will write some code for bus, but first we will extend the vehicle class because we are driving from the vehicle class. That's why we will write code extends and we will type vehicle class over here, and inside this particular class we will write some specialized code for the bus class. So now here you can see that I have written some code, one particular variable or the class variable for this particular bus class. This is a class variable or member variable for the bus class which is specialized for this particular class, and we have a new method which is a constructor, and we are also initializing by the constructor, and we already have the height and width, and it will call the super, and if we'll call the super, so height and width will be initialized if we will create the object of this bus class. And also we have to initialize the value for the seating capacity, so that's why this line is there. And if you want to print the height, width and seating capacity for this particular bus class while we are calling the constructor, so you can utilize this one, or you can write the comment, because in a practical scenario or the real life case, this line should not be there, and any printing statement should not be there in the constructor. And also we have a run which is actually calling the super, so it will actually call the run method which is present in the vehicle class, that means parent class, and it will also print its own specialized information that it is a bus class, or we are in the bus class, or we can say that bus class is running. So this way we will be able to understand that bus is also called, also super methods run also called. So super method is here, so you can see this code or this information will be printed when we'll call the super. And you can see this info message is there in the vehicle class only, so we can also call this particular behavior from our child class and bus class. So we have a vehicle class which is parent, and bus class is the child class, also car class or the child class. So how we can actually run this code or call this particular hierarchy? So for that we will create another class which is the main, which will contain the main method. So here I will add one item, I'll select the class, and this time we will call it test class. Okay, and now I'll add it. So here you can see that we have test class. So we have created class, but if you will create a runnable job, it will be better, because that time you will get the main method automatically. But here if I'll take the class, then I have to type the main method manually. So I'll type the code and create the object. So now you can see that our main actually here, and we are creating the instance of the car class. How? We have to give the name of the car class, then this is the object of the car class, then we have to use the new method or the new constructor to initialize the value, and inside the car class we are passing the parameters 1.5, 2.0 and 4. Why? Because car class is actually taking height, width and number of passengers. So height, width is real and number of passenger is integer. That's why this is 2 is real and this one is actually 4 number of passengers. So if you'll hover over here, it will show you the suggestion that real height, real width and integer number of passengers. So this way you can take the help from the Visual Studio Intelligence when you are creating the object, and using this object you can call the parent class info. Info is not present in the car class, you can see info is not there. That means we are calling, or we are actually accessing the behavior of the parent class, and when we are calling the run method, it means car class, run already overridden. What is override means? Here you can see that we have a parent class, parent method run, and in child class we have also a run method. So that means it is a method overriding, and when we are calling method overriding, it will actually calling the super. It means it will also print the information which is present in the vehicle class. Also this will print this two particular information in the child class. Okay, and in this 3 statement we are doing the same thing for the bus class. Okay, so in the bus class you can see we are creating the object, and here it is taking real height, real width and integer seating capacity. So here bus's seating capacity is 30, So that's why I am passing the parameters or the argument as a 30, and from here using the object we are calling the info of the parent class, and we are also calling the method or the behavior of the bus class. And if we go to the bus class, in the bus class, and you can see there is a run, it is also asking, and it is also calling the super, which is means it will call the behavior, run behavior from the vehicle class, that is the parent class, and it is actually printing in its specialized information, that is bus class is running. So you can utilize this facility, and you can write many properties or many behaviors inside your class. If you understand the concept, it will be easier for you to apply it in the real life. This is also a small practical example for the real life example, but in the practical example, when you will work for an organization, for a company, they have the set of business rules. Based on that, you have to create your logic. Okay, right? We'll go back to the test class, and when we run this, it will actually call the run method of the child class, which is the bus class, and it will call the vehicle class also. So I hope the explanation is a little bit easier for you. Now I will add the debugger point over here, and I will show you how this code is actually working or executing, and the flow of the execution, how it is going from object to methods and class. So let's see. So first we will add the debugger point over here, and I'll set here. I also set here also, here also, here also, in the child class also, here and here, and I also add here also and here, all the code by clicking on the save all button. Now I'll go to the test class, and I'll start the debugging, or the start button I'll click. So before starting, you have to make a startup object, otherwise it will throw an error. So set as a startup object and then click on start. So you can see here the program is actually executing, and it will take some time to execute, because if you are using the free VM or in dev machine, it will take some time. So you can see that in info log there is nothing, and in autos here you will able to see all the variables, how the variable is actually creating here in the memory and their particular value. And now you can see the debugger point is here, car class, car, and now in there we will, car is null because it is not created. If we will click the step over or F10, our object will create, and it will go to directly the car class constructor, and here you can see the height, width and number of passengers passed via the local variable. And if we'll click over here, it will go to the super means it will go to the parent class constructor. So if we'll click over here, you can see that now I am in the vehicle class, and it is passed the value height and width. So if we'll step over here, so you will be able to see the height, width will be initialized. Okay, so if we'll click here, you can see that now it got its value height and width. So if we'll click over here, it will come back to the super line, and it will initialize the number of passenger. How it will take, you can see now the number of passengers is 4 now, because of this line it's initialized. Now it will go to the object here, and it will call the car.info. It means it will directly go to the parent classes info method, and it will print. In info message, info log you can see nothing is there, but when it will execute, it will keep the result. So because of this line, it is printing vehicle 1.50 and 2.0. maybe I pronounce it 15, but it's 1.50 and 2.0. and now it will go back to the test class, and again it will call the run method if it will step over. So it will go to the car class. It means that if so in the test class, what you have seen, for the info message there was a no method in the child class. That's why it's directly accessing the parent class info method, which is very much important. How it is actually utilizing the behavior of the parent class, we can understand by that line. But in case of run method, as we have overridden the run method, so it is directly coming first to the child class. So that's why we are in the car class here. So if we'll step over, and if there is a super, so if there will be a super, we are calling the super, then it will go to the parent class run method, and it will print what it will print, vehicle class is running. So you can see that in info log, vehicle class is running is actually printed, or in info log you can see that. So now if you will step over, it will go back to the child class run method, and it will print its specialized information, that is car class is running, and height and width and the number of passengers. So you can see the information. Now the info already executed, run also executed. If we'll step over, it will create the object for the bus class. So this is also a child of the parent class. So it will go here, and it will initialize all the member variables. So this is somehow similar, so that's why I am not explaining each and every point. I am just stepping over. You just see from where it is going, and I hope you will be able to understand it. So it will go to super will initialize the height and width. Again it will go back to the constructor, and it will initialize the seating capacity, and it will call the information from the parent class, that is info vehicle class, and it will print for the bus, and it will go back to the test class, and it will call the run of the child class, that means bus class. This time it is calling the bus class because we are our object is bus. So it will call the super, and it will print the information from the vehicle class, that vehicle is running. It will go back to the child class run method, and it will print the bus is running. So you can see all the information over here, and it will go back to the test class, and all our code executed, and it will end our program, and it will show all the information in our front end. So you can see all the information over here, right? So I hope you understood the concept of hierarchical. So in this example, I have just taken two child class, bus class and car class. You can take any number of classes. You can take tractor class, you can take Ola, Uber, whatever you can take, but it should have the hierarchical relationship. Okay, otherwise the logic will be mess up. So I hope this is clear for you. So if we'll go back to this diagram, so this is our vehicle class, this is the base class, a parent class, and we have another class, that is the drive class. This is our car class, and this is our second class, that is our bus class. And if you want to create one more class, you can create the tractor class, and you can add more class also over here like this. Okay, but for the sake of simplicity and easy to understand, I have taken only the car class and bus class. So I hope this is clear. So in summary, I want to say that hierarchical inheritance in X++ programming language, as applied in D365 Finance and Operations, it promotes a well-organized, modular and efficient approach to software development. It empowers the developers to create classes that builds upon existing functionality and leading to more maintainable, extensible and adaptable applications. So thanks for watching this video. Take care. Bye bye. See you in the next one.